2.2. Here we go. Let's check it out. Okay. So in 2.1, their focus was of the derivative at a point, A. So some specific point we're finding the derivative of. And now they're saying that, well, you know what? The derivative could be thought of as a function, and that you found that would represent the derivative at many points on the curve, and then you could do things with that function. So that's the reason, a slight notation change. A is a fixed point, like 8 or like 4 or wherever, and X is representing any point that could be on the curve. And so that's what they're, and you might be thinking, well, it's really small difference, and I do agree with you there. But the thought is a big thought, right? So the small difference in the formula is a big thought difference. So here they're asking us, this is problem 26, find the derivative using the definition, state the domain of the function, and also the domain of its derivative. So let's start off by saying the domain of the function. So the domain of f, well, the denominator can't be 0. That wouldn't be allowed, right? So we know that 2x minus 3 should not be 0. And so when we solve this, 2x shouldn't be 3, so x shouldn't be 3 over 2. And you can write this in interval notation. I'm leaving out 3 over 2, right? So the domain of f in interval notation is negative infinity to 3 over 2. And I know we've talked about it 100 times. Some people use union and then 3 over 2 to infinity, and some people use comma, and the WebAssign takes either, and in the book I think they have comma. And in the back of the book, I'll have to check that to remember, because I know that in one chapter it was comma, and the other it might be union now in this chapter. I don't know. Anyway, I'm putting union today. That's how I'm feeling. Let's be united. Okay, so they're asking me to find the derivative. So I'm going to use this definition here. There's another definition that I could certainly also use that we looked at in the last chapter, but this is the one I want to use right now. So I'm going to do that. So if I put in x plus h, if I plug that in, the limit, as h goes to 0. People say, hey, you write the limit over and over again, and you must get tired of writing that. But so I decided not to write it. And you need to write it until you take the limit. And so these things, when they ask you to find the derivative by the definition, it's more like a proof than it is just about finding the answer. And so you need to write your limit. And so I'm going to be plugging in into the blank, if you like to think of the blank. Into the blank is going to go x plus h. So I'm going to have here x plus h squared minus 1 divided by 2 times x plus h minus 3. And if I had a nickel for every time that a person made a mistake on this part because they did not use parentheses, I would be rich, 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 beyond rich, right? Now I'm going to put in x there, and because it's not a binomial, I don't really need the parentheses, so I'm not going to write them. I'd be so rich, I'd be buying a little island and living on it. It would... This morning, it seems like it would be really fun to be living on a deserted island. Okay, so I'm looking at that and I'm thinking, certainly this is 0 over 0. That's what they always are, right? 0 over 0. So if you put in 0 here and 0 here, you can see that this is going to collapse down to be exactly just that, over 0. So it is certainly 0 over 0. I usually don't take the time to note that, which means that it's indeterminate form. and I've got to work a little harder, right? And so you can see that I'm going to have to clear the fraction here. That's what I would do. So, and your choice whether or not you write this as 2x plus 2h minus 3, which I'm gonna say that that's what it is. So I'm going to be multiplying, I don't know why I got by 2x plus 2h minus 3 times 2x minus 3 to the numerator and to the denominator. So that's going to be, so I'm really multiplying by this. I'm usually too lazy to write it over, but that's what I'm going to be multiplying by, which is 1, right? And so it should leave it looking different, but having a value that's unchanged. And so when I multiply this to, this is my numerator, you can see what happens when I multiply this by this monomial to this binomial. I'm going to have to distribute, and this is going to drop out with that and leave just this crazy numerator and that. So this is going to look like the limit as h goes to 0. Some big time algebra here, right? 2x minus 3 was left over, and x plus h squared minus 1 minus, so I distributed this to that. This and this canceled out and left this piece, and that piece. Now I'm going to, remember I'm distributing it, right? So now I'm going to distribute this to this. The 2x minus 3's are going to cancel out, and it's going to leave us the x squared minus 1 and the 2x plus 2h minus 3, all divided by this denominator times h. So I'm going to write the h first and then this denominator. My choice, whichever I write first. And I can change my opinion of what I would want to write first at any given time, right? Okay, so I multiplied by 1, and it's still in indeterminate form. If you were to put in h as 0 right now, you would notice that you're still at 0 over 0. But now I got to multiply all this stuff out, and that's what's going to be hard on my algebra. So when I multiply x plus h squared, I'm going to come up here and I'm going to write it up here. X plus h squared is x plus h times x plus h, which is x squared plus xh, whatever order, xh plus h squared, which is x squared plus 2xh plus h squared. And but you could use the binomial theorem. You can multiply that in your head. You can get used to the fact that they have you multiplying that a lot of times, sometimes even raising it to the third. And so this is going to be 2x minus 3. Then what we just FOILed out, x squared plus 2xh plus h squared minus 1 minus, and then there's nothing to do but multiply that stuff together. You can't fix up the pieces. And of course I'm hoping to cancel the denominator, the h in the denominator. So I'm not gonna multiply that together, because then I won't be able to reduce the h out. So somehow when I multiply this all together and subtract it, that I'm going to have a common factor of h when I'm all done. And I'm going to factor that h out, and then the h's are going to cancel, and then my 0 over 0 will be gone, and I'll be able to plug in h is 0. So that's my goal, and this is going to get really algebra-y here, because this is going to be 2x cubed, right, plus 4x squared h, so 2x times here, 2x times here, 2x times here, plus 2xh squared times here, minus 2x, and then the 3, minus 3x squared minus 6xh minus 3h squared plus 3. And I probably should have multiplied this together here, because otherwise I'm going to have to do it in 2 steps. And now I'm feeling like I would rather erase, because I'm going to have to distribute the negative. So this is going to be 2, so I'm multiplying x squared times 2x is 2x cubed, x squared times 2h, 2x squared h, minus 3x squared, and then on the inside, minus 2x minus 2h plus 3. So now I can distribute, right, like I distributed times negative 1 there. Minus 2x to the third minus 2x squared h plus 3x squared plus 2x plus 2h minus 3, all divided by Okay, so remember what I said was going to happen. And so if it doesn't happen, I'll go back and check my multiplying. But everything that doesn't have an h on it is going to reduce out to 0, subtract out to 0. So 2x to the third minus 2x to the third is 0. I have some of those like terms that I can combine, right? 4x squared h minus 2x squared h. And I didn't think these were going to make 0, right? Because I said that everything that doesn't have an h on it is going to go away. And so I'm not worried about this staying because it has h on it. So that is 2x squared h. And is there friends to go? So I got rid of these. So a 2xh squared I don't see any of those. So plus 2xh squared, I did that, minus 2x plus 2x minus 3x squared plus 3x squared minus 6xh, I don't see any of those, minus 3h squared, so I got that, 3 minus 3, so those are gone, and then plus, I already got rid of this one, that's why I had to cross them out, friends, because there were so many of them that I thought that if I don't cross them out as I write them down, you notice everything has h on it in the numerator. And I knew from the beginning, because of experience, that that they would, and if they didn't, that I made a mistake somewhere. And it would be easy to make a mistake in multiplying there. And just because you made a mistake in your multiplying doesn't mean you don't know how to multiply. It's just easy to make a boo-boo. Now I'm going to factor out an h, and I'm going to cancel it. And then I will be able to apply my limit. So I have not applied my limit yet. So I'm factoring out a h. And I already have an h in the denominator factored out because I didn't multiply it together. So the h's drop away, and now it's no longer, when I substitute, 0 over 0. So now I am going to plug in h is 0. So that should have had an h on it, right? I was looking there and I was thinking I had no like terms, so how am I having like terms now? And It is easy to make an algebra mistake. Okay, so now, and I said I was going to check it, and then I didn't. H times this is this. H times this is this. H times this, H times that. Okay, so now the H cancels out, and I'm going to plug in H is 0. So when H is 0, this term is going to go to 0. This term is going to go to 0. This term is going to go to 0, right? And so this is going to leave. I won't write my limit because when I substitute in H is 0, I'm applying the limit. So this is going to be my derivative. And I'm done with the limit because I've applied it when I plugged in. So I'm going to have in the numerator 2x squared minus 6x plus 2. And in the denominator, I'm going to have 2x minus 3 times 2x minus 3. And I was looking to see if that looked like it would reduce to me. 2x minus 3 with something in the numerator. And I can certainly factor out a 2 in the numerator. And when I factor out the 2, I can see that it's not going to cancel. I could write 2x minus 3 squared. I can see that it's not going to cancel with the denominator down there, right? Because when I factor this, it's not going to have a 2x minus 3, right? Because it's not going to have a 3, it's not going to have the 2. So this is a good answer. Having that numerator before I factored it was also a good answer. Writing it twice is a good answer. Having it as square is a good answer. So all of those are all lovely, wonderful answers. Okay, so we did a lovely job on that one. It was Algebra City. I remember exactly, I had Calculus 1, I had actually Calculus 2, and also Calculus 3 and differential equations and linear algebra at Bakersfield College before transferring to UCLA. And I remember my teacher, Mr. Moretti, learning these in his class, and I would always mess them up because of the algebra. My algebra was terrible. I was terrible at algebra. I got better at it by practicing. And I've told you guys many times that you need to find a student that's learning algebra, and you need to tutor them, and you need to pay them for the privilege of tutoring them instead of vice versa, because it will help you more than it helps them, believe you me. And so anyway, I remember exactly where I was when I first figured out the derivative using the definition. I was supposed to say the domain too, so I'll have to say that as well. And it was on a train ride to see my friend at UC Davis. And this couple sat down at the table with me on the train in Bakersfield as we were driving, and I was trying to figure these out. I had my calculus book out and whatnot, and they asked if they could share the table with me, and they had a baby, and pretty soon they were like, oh, well, the man was like, I've had calculus, and so, he immediately needed a piece of paper, because calculus is so fun, and a pencil, and him and I were figuring these out. And this distributing right here that I did seemed to be a problem, that I did not get the parentheses in, so I did not get it distributed. And anyway, so that was something that was always messing me up on it. And I remember that somewhere along the way, we got stuck on a really hard one, and he asked he said to his wife, well, you had calculus too, you help us. And so I've now given her some paper and pencil so that she could be writing away, and we were all just working away. And I remember as we passed Fresno, so 2 hours later, Bakersfield to Fresno, right, somewhere along there, I was holding their baby, and they were both busy doing calculus away. I mean, just to show where the interest is. Okay, the domain, do you guys agree it's the same? Because the denominator should not be 0, and the denominator would not be 0. We need to leave out x should not be 3 over 2, right? This was twice, but the same, right? 2x minus 3 should not be 0. So the domain of the derivative is actually so this is of f prime of the derivative is actually the same as it was. And so you could write that in interval notation. So, okay, we did a lovely job on that. Oh no, it's going to take a ruler. Okay, now they're wanting us to get the idea of what the derivative is. So it's not really how accurate you are on this, it's that you get the idea of what you're finding. And so when they ask me to find f prime at -3, they're not asking me to find f at -3, a point. They're asking me to find the slope of the graph at -3. So in Stewart fashion, doesn't have this labeled. So I'm going to do a little labeling on it. So they're asking me to find the slope at that point right there, to estimate the slope at that point. Now, a way of estimating the slope, and there's different ways of going on it, but a way that I have found kind of good is that you're trying to figure out and draw the tangent line. So I'm trying to draw a line that looks just like the curve at that point, and so that's just tangent to it. And then what I do to do the estimate, and you can do it differently, it doesn't matter, is then I try to come up with another point. I can choose this one over here if I like, or that one right there, and then find the slope through those points. And so either way, and you can count it if you like. And so maybe this one, just because that one is so close, I don't know, you know, what am I going to estimate that to be? What am I, or this one, should I use? I don't know, doesn't matter. Okay, so, and you can count it. Remember, slope is equal to, or you can name those ordered pairs and use the slope formula if you like, but I am just kind of estimating. Slope is rise over run. My teacher, Mr. Heater, taught me to count the run first, and you can count whatever you like first. And so I was taught to count the run first, the denominator, and so 1, 2. So the run is 2. And I was taught to count the rise second. So I'm going here, and I'm going here. So I know it's down, so it's negative. And so what is that distance? And I'm just going to kind of, you know, eyeball that distance right there. Don't get out a ruler and measure it. Maybe 0.7. Is that distance there from here to here? And so, long story short, then I would be estimating my slope there to be like -7/20. Okay, so, and there's different answers. So some people might say, well, I thought that was really, because remember it was estimate, I really thought that was closer to half, -half down, and so I could kind of be convinced that that's might be half as well. And so another person, so this was f prime at -3, might be saying, well, when I did mine, I thought it was negative this over here. And when you do that one, -0.5 divided by 2, it's -4th, and so it is certainly looking nicer, right? And so this one was -7/20. And so whichever one, whichever, I mean, somewhere in that range, they're not very different from one another, and they're just trying to get us the idea of that it's the slope at a point. And so here at -2, and when I eyeball that, right, that looks horizontal to me. So this looks like this is 0. So it's a horizontal line, so it looks to me like it's 0. And then here at -1, so I'm going to use my my approach. So now I'm over here, f prime at -1, and remember that's the rise over the run. And I was taught to count the run first, so the run is 1. And the rise looks to me like the rise is also 1. Looks really close anyway, so maybe 1 on this. If you said that that was 0.7 or 0.8, then that's what you would have for your answer. And then at 0, yeah, I'm going to go 0.8. I was kind of convinced it was 1, and then I'm more carefully looking at it and thinking, no, it's not. So here I am at 0, and I'm drawing that in. Okay, so I'm trying to get a point. I'm going to use this point and that point. Oh no, I want to use this point because I want to go over 1. So at 0, f prime at 0, right, rise over run. I drew my line in there at 0. I'm going to use this point. I'm going to go over 1 and up 1.5. So 3/2. And then you can go and do at 1, and you'll notice at 1 matches -1. So whatever you said for -1 should be the same. If you said that was 1, remember I originally had 1. And at 2, it's horizontal. 0 is the slope. And at 3, it's that same because of the symmetry. So whatever you said, if I put -7 over 20, maybe I'm going to put -1/4 just because -1/4 is a little bit easier. And they're really close to one another. Okay, and then they're wanting me, after I've done that, they're wanting me to make a graph, sketch the derivative. So they find all those points, and then they're wanting me to sketch it. So you're going to put these slopes on here. At -3, we said the slope was -1/4. So that was about here. So the x value is -3. The y value is -1/4 for this is y prime for the slope. And at -2 was 0. And at -1, it was 0.8. Maybe you said it was 1. And at 0, it was 1.5. And then mirror image, right? So somewhere along this line is the graph of the derivative. So here's the function, and here is the derivative, kind of sketched in there. Okay, so that's all they were wanting us to do. They were wanting us to estimate, and why they want you to do this is they want you to get the idea that the derivative is the slope, so that you're estimating the slope at all of those points of the curve. So that's what they were wanting there. And just some notes, points where the function does not have a derivative. So the derivative does not exist at a corner. So right here at x is 0, the derivative does not exist. The derivative does not exist at a cusp. And so right here at x is 0, the derivative doesn't exist, coincidentally at 0. All of these are coincidentally at 0. So it's not that 0 has a problem. It's just that, so if this cusp had looked like this, then trying to draw a cusp right there, and this had been 1, then I'd said the derivative doesn't exist at 1, at x is 1, right? And so anyway, at a discontinuity like a hole in the graph or a jump or an asymptote, the derivative doesn't exist. So there's an asymptote right here at x is 0, coincidentally. And so the derivative doesn't exist here at x is 0. If I had a function and I asked you, and I had a hole in the graph, say right there is my hole in the graph, and that hole in the graph was at 2, then the derivative would not exist at x is 2, right? So at the hole in the graph, and if you had a jump discontinuity, it wouldn't exist there at the jump discontinuity. And it doesn't, the derivative doesn't exist either at a vertical tangent. So you can see the slope of the curve right here, instead of being horizontal, it looks like it's straight up and down. It's vertical, and the slope is undefined. So the derivative is the slope, and it's undefined at this point right here. So the derivative doesn't exist there. So just trying to get the idea that the slope is the derivative, they ask again to you, they say, the graph of f and f prime are shown, and it's kind of blotchy because I did photocopy it out of the book, and then or whatever, so that I could use the problem from the book. And then blew it up a little bit. You know how that can get exaggerated. So the first thing I have to decide is, well, which graph is f and which graph is f prime? And they did not label them. And some of them, it's really, really easy to tell the difference between f and f prime. And this one's trickier because some of them, all you have to do is look for the zeros, and then you're in business. So right here, the slope is 0. And I notice that the other curve is 0. So this could be f, and this could be f prime. But look how it goes here. Here, the one I was saying, here is the slope is 0, well, the other curve is 0. So this could be f, and that could be f prime, which is opposite of what I just said. And so, and you go, if you go to every one of these zeros, you'll notice that you don't get it. And some of them you do. So that if the slope is 0 and the other curve is 0, and that never happens for the other one, then you found it, which one's f and which one's f prime, by just looking at the zeros. So I have to actually be trickier on here. And so right here, if I look at this, the slope is positive all the way to here. The slope is positive because it's going uphill. Well, then that would mean the other equation, if it was, so if this was f and the slope is positive here, the other equation, f prime, would need to be totally above the x-axis to all be positive. And that's not true. So when I was supposing, you know, and looking at this slope being positive, I was saying, could this graph be f? Is what I was thinking. And question mark. And if it was, then the other graph would then be f prime. And then what, question mark, right? And then because the slope is positive here, this f prime would have to all be above the x-axis. And that's not true. So I know that what I just supposed here can't be true. So it has to be the other way around. It has to be that this one is f prime, and that this curve is f. And then let's just see if we can find any contradictions there, right? And so I wrote this one being f prime as well, and I'm like now looking at it and thinking, what the heck? Okay, so I'm looking for contradictions. So from here to here, this is uphill. The slope is positive. right? All from here. So I'm kind of looking, dotted line here. And that would mean that f prime would have to be above the x-axis all the way to here. And you notice that it is, right? This is uphill. So if this is f, then the other curve is f prime, and then f prime, because this is positive, would have to be above the x-axis all the way to there. And you notice that it is. And here, the slope is 0, so f prime should be at 0. Here, the slope is 0, so f prime should be at 0. And so you can see that, oh, well, those go together. I didn't immediately find a contradiction, right? And so, and you can go everywhere and see that that's true. So I'm saying that this darker one is f, right? So this is f. So if I start here, saying this is f, and this one's f prime, then the slope should be 0. It is, right? It's going downhill, so the slope should be negative, which would mean that f prime should be below the x-axis. That's where the negative values are. And you notice that that happens all the way to here where the slope is 0 again. So this is, it should be negative, and so it should be below the x-axis, and it is. So now I have figured out which one is f and which one is f prime. And so now I can start to see if I can figure out, well, what is f prime at -1, and so we're going to look at that and see if we can kind of tell what we've got going on here. Now it didn't have any, and now I've written all over this, and it didn't have any, you guys are going to remember which one's which, right? Try not to erase which one's which. It didn't have any grid on it, right? I don't know where -1 is. I don't know where 1 is. That was my arrow, right? That's not a 1. And so I kind of have to estimate and just kind of see what I think. And so f prime at, I think it did have grid mark on it, so that would make it easier. This is, I think it did have the grid mark on it. And so I might have to get my book out and make sure of that, because I'm now saying it does. So f prime at -1 is that value, whatever that height is, some positive value. And then f double prime at 1, so this is some positive value, whatever that height is. And f double prime at 1 means look at the slope at 1. So this means look at the slope at x equals 1 on the f prime graph, right? Because the slope of the slope graph will be the second derivative. So I want to look at the slope when x is 1 on the f prime graph. So here I am at x is 1, and I want to look at the slope. So I'm looking at the slope to compare it to this. So here I was looking at f prime at -1, so I was looking at what the y value is. But because it's another prime, I'm looking at the slope there, and the slope clearly is 0. And they asked me which one's bigger, and so I know then that f prime at -1 has to be bigger. And so anyway, so that's kind of that story. You could also look at, if you wanted, this is the slope of the f graph at -1. So I could come over here, and the f graph is this one. And so what is that slope? Well, it's some positive value, right? And so that's enough because the other one was 0. Okay, so that's all that they were wanting you to look at and do. So the slope is the derivative. Okay, they asked us to sketch the graph of this, x plus x, absolute value of x. And I think the easiest way to sketch the graph of this is to get rid of the absolute value, instead of trying to think of how would the shifts in the translations be on this thing. And so I think what I would want to do is I would want to write this. This is x plus the absolute value of x. Now remember that this is either x or negative x, depending on what x is. So this would be, I always leave it the same in the numerator. So when it's x, this would be x plus x, right? Because I already had this x, and then it would be this. And then the other one would be x plus negative x. And this was if x is greater than or equal to the inside 0, right? The inside's x. And this is if x is less than 0. So just the conditions on that. And so this is either 2x, and this is if or when x is greater than 0, and this is 0, and this is if x is less than 0. So now that I've done that, I can sketch it pretty easy because it's just 2 lines. And so on this side, over here, when I choose, right, g of x equals 2x, and I'm going to choose values for x that are 0 or bigger, and I know it's a line, and so I'm going to get 0 and 2, and of course, and it's solid here, solid, and over 1 up 2, and of course, I'm just making a sketch. And so I've really worked hard for a sketch. So it's a line that looks like that, and then it's horizontal. G of x equals 0 is a horizontal line. Horizontal line, right? And it would be open at 0, but that it's already closed by this other one here. So this is a horizontal line right here, and it would be open at 0 because it doesn't include 0. So the height of this horizontal line is 0, but the other included 0, so it's closed because this one closed it. Had they not come together, they did come together, but had they not come together, piecewise defined wouldn't have to come together, but if they hadn't come together, then we would have to open. Okay, so you see that we have made a corner there. So it says, for what values of x is g differentiable? And so we know that it's not differentiable at a corner, but it is differentiable at a horizontal line, and it is differentiable at a slanted line. And so this is not differentiable. Can't find the derivative. That's what that word means. At x equals 0. So they wanted to know, where is it differentiable? So everywhere it's not differentiable at x, but so everywhere else, right? So I just want to leave out 0. So this is where I would be able to find the derivative. Anywhere at any value between negative infinity and positive infinity. Then they're asking me to find a formula for g, is what they're asking us to do. And so remember that the derivative is the slope. So I could whip out my formula. G prime equals the limit as h goes to 0 of g of x plus h minus g of x divided by h. But that would be a lot of work when remember what it is it's the slope, right? And so what is the slope over here? The derivative is the slope. Well, it's 2, right? It's a slanted line, and the coefficient of x, right, is the slope, and it's 2. And what's the slope over here? Yeah, the slope is 0. And what's the slope right there? The slope right at that corner is undefined, right? So we can't find it right at that corner. And so the derivative is undefined at that corner, or the derivative does not exist at that corner. So my formula for G is going to be 2 as long as the slope, right, as x is greater than 0, not equal to 0, because at 0 something else happens. So as long as I'm greater than 0, the slope is 2. And the slope is going to be 0 because it's a horizontal line as long as I'm smaller than 0. And then the slope is undefined at 0. So we did a lovely job on that, so I'm not going to mention it. Okay, so that's section 2.2.